historical data, mostly coming from satellite images of temperature, sea level, and rainfall, and changes with respect to climate. As you can see, in some areas like the northwest Luzon, they will be experiencing a lot of changes, including extreme rainfall events such as the one experienced during Andoy. In the Pacific side, almost the entire Pacific side will be experiencing very high increase in ocean temperature, equivalent to more than twice the global average. But what is common in all of the typologies is the symbol of sea level rise. That means everything, the entire Philippines will actually experience significant amounts of sea level rise, just as our previous speaker shared, accounting for about twice to even 3 times that of the global average. So people will experience increasing sea level rise, exposing more and more of their houses to increase in erosion. The 2019 population showed the Philippines as having 108 million people, and like D.S. Ligarde said, 60% live along the coast, so this is about 64 million people. If only 1% of that actually lives right at the coastal area, we're already talking about 6 million people exposed directly to sea level rise. And according to this global estimate, the Philippines is colored red, which is about 1 to 9 million exposure of people living right at the coast. So this is about what we're estimating. Thus, communities such as this, fisher communities where they live at very low-lying islands, will be at the highest risk. So these types of communities will either disappear, or as Congressman Chato shared, they will have to adapt with houses on stilts and the like. So if you take a look at the blue line, that is the average sea level height at the moment. So all the propagules are above that average sea level height. They will experience inundation once in a while during high tide. But with just a few millimeters of sea level rise, that average height will increase. And therefore, what is now the place for propagules to grow, especially that of Abyssinia and Sonoracia, the salt-loving ones, they will be the ones that are exposed. And studies have shown that exposure to higher salinity during the time of growth from propagule to seedlings would affect their survival rates. It would affect the cumulative shoot height, the mean growth rates, the mean total leaf area, and the mean dry weight. So that will be compromised. Equally, you will also compromise the species at the very back, which are only salt tolerant. They can survive intermittent inundation. They will not die because of salt. But if they're constantly under a very saline environment, they will also die off. So you have your case of die off of the very back and slow die off of the very front, because the new propagules will no longer survive. If there is no development at the back of this mangrove forest, then naturally all of these will just grow farther and farther away from the ocean and will survive as an entirety. But if there are buildings at the very back of these mangroves, or houses, or roads, then that will prevent them from migrating naturally on higher ground, and they will die off. And so it has cascading hazards and cascading disasters. When Haiyan struck in Palompon, Eastern Samar, they face a storm surge up to 3.6 meters high. Their structures are only about 2 stories tall, and therefore they could easily have been wiped out. But if you see at the very top of this picture, There is a mangrove plantation located on an island a few hundred meters from the shore of where the town is, and it actually buffered the full impact of the waves. So, according to the LGU, the mangroves saved them. Without these mangroves, if they die off, there will be increased exposure to storm surge of these types of communities. So, it will increase exposure, that's a cascading hazard, and it will therefore expose the towns that are coastal, therefore creating cascading disasters. Aside from this, mangroves are known to be good sediment traps. So especially the species of Avicennia marina and Sonoracia alba, they are known to hold sediments up to 10.5 kilogram per square meter per year in the intertidal zone and up to 39 kilogram per meter squared per year in the mid-tidal. So if these die off, all these sediments will actually be open for erosion, and you will have increased sedimentation in the water column. Next slide, please. That coastal sedimentation will go into the nearby habitats such as seagrass and coral reefs. At the very least, it will create murky waters or low light, decreasing the photosynthesis of the seagrass, increasing the epiphyte densities, and eventually it can cause seagrass aggression. If the sedimentation is really high, then it will actually engulf corals, increasing their vulnerability to bleaching events, or eventually mortality if they're completely engulfed. Next slide, please. Again, this creates cascading hazards. A cascading hazard is a sedimentation. So from a die-off of mangroves, you have a cascading hazard of sedimentation, and you end up with a cascading disaster of decrease in biodiversity and biomass of the fisheries associated with these habitats. So we know that studies have shown that if these three habitats are present in a certain site, you have very diverse and high biomass of fish. If only one of these disappear, then there's a drastic decrease in both biodiversity and biomass. So that's a cascading disaster for the environment. In addition, therefore, the problem is how this will affect our fishers. So about 1.6 million there are about 1.6 million fishers in the Philippines. 27% of these belong to the municipal fishery or fishery which is associated directly with these habitats of coral, mangrove, and seagrass. So if these start dying off, we're talking about loss, not only of food availability for the entire Philippines, but labor, loss of livelihood for our fishers. So if we combine the two, the increase in sea level rise and the exposure to increase in sea level rise and therefore die off of all these habitats, we have these provinces. We analyze that these provinces are the ones that are at highest risk. So ARM, we have Sulu and Tawi-Tawi, we have Cotabato City in Region 12, Bulacan in Region 3, Bohol Cebu in Region 7, Eastern Samar in Region 8, Masbate Camarines Sur in Region 5, Negros Occidental and Iloilo in Region 6, Batangas, Quezon, and Cavite in 4A, Palawan in 4B, Zamboanga del Norte and Zamboanga del Sur in 9, and Pangasinan in 1. In addition, if you take a look at this, where the fishers live, these municipalities outlined on the very right side of the table show you where there's also significant inundation, where you actually have to either really adapt on houses on stilts or take away the fishers from those areas. So they will be the hardest hit. Finally, there's a loop, which comes first, the chicken or the egg. If you start losing these mangroves and also the seagrass, you're talking about the release of already sequestered carbon in the amount of more than 1,500 tera carbon dioxide per hectare of loss. So imagine, not only will you have disasters, but you're actually going to perpetuate an even higher increase in temperature and therefore sea level rise. that's it. Thank you.